This video discusses solving story problems using right triangle trigonometry. So I've done several videos about what right triangle trigonometry is and how to solve for missing sides and angles. We're now going to take that and apply it to solving story problems. So in bold right here, it says for each of the following, draw a picture and then solve for the missing variable. Drawing a picture is really useful when solving story problems of this type. So I'm just going to start right away with number 1 that says, according to the Americans with Disabilities Act, a ramp can rise no more than 1 foot for every 12 feet of horizontal distance. So for me, what that's saying is, okay, the ramp can only be 1 foot off the ground, so from ground to top, it can only be 1 foot for every 12 feet of horizontal distance. So this would be my 12 feet of horizontal distance. So this is my triangle here. Since this is right triangle trig, you should always end up with a triangle of some sort. And then the ground and the edge of the ramp should be a right angle. So what is the maximum angle that a ramp can form with the ground? So this is my ramp right here, and here's the ground. So this is my angle. So I just need to solve for this angle, and then I'll be able to answer that question. So if I look at this angle, I know the opposite side and the adjacent side. So if I think of my sine, cosine, and tangent, the only one that uses opposite and adjacent is tangent. So the tangent of this angle, the tangent of x, is equal to the opposite, which is 1, over the adjacent, which is 12. So the tangent of x equals 1 over 12. So to solve this for x, I can take the inverse tangent of each side of my equation. So this will cancel, and x will equal the inverse tangent of 1 over 12, which can be put right into a calculator. So generally, your inverse tangent is right above your tangent button, so you would hit second tangent. Not true for all calculators, but for many. So the inverse tangent of 1 over 12 is about 4.8. So the maximum angle this can be is 4.8 degrees. So that was just one example. I'm going to do several more, but as you can tell, even from that one example, this picture is very important. If I hadn't drawn that picture, it would have been really hard for me to figure out what I'm trying to solve for. So let's look at number 2. To guard against fall, a ladder should make an angle of 75 degrees or less with the ground. What is the maximum height that a 20-foot ladder can reach safely? So I'm thinking of, I have a ladder here, leaned up against a wall, and it says that this angle the ladder makes with the ground should be at least 75 degrees. So I'm going to go ahead and call that 75 degrees. And it wants to know what the maximum height is, so this would be my height over here, that a 20-foot ladder can reach safely. So my ladder is 20 feet long. So again, once I have my picture, I can quickly and easily see what I'm trying to solve for. So I want to solve for height. So if I look at this angle, I'm trying to solve for the opposite, and I know my hypotenuse. So again, if I remind myself of the 3 trig ratios, the only one that uses opposite and hypotenuse is sine. So the sine of 75 is equal to the opposite, which is the height, over the hypotenuse, which is 20. So to get this height by itself, I'm going to multiply by 20 on both sides. So then these 20s cancel, and my height is equal to 20 times the sine of 75. So if I go ahead and enter that in my calculator, 20 times the sine of 75 is about 19.3. So this can reach about 19.3 feet safely, not any higher. Number 3, Mr. Boone is building a wooden ramp to allow people who use wheelchairs easier access to the public library. The ramp must be 2 feet tall. So kind of like the one we did number 1, we want our ramp to be 2 feet tall this time instead of 1 foot. Find the angle of elevation if the ramp begins 24 feet away from the library. So we're going to start 24 feet from the library. So here's the library right here. That's where the ramp ends. And then here's my ramp. And it wants to find the angle of elevation. So right here. So I have the opposite and adjacent, just like I did on number 1, which is tangent. So the tangent of x is equal to the opposite over the adjacent. So if I take the inverse tangent of each side here, then I have x equals the inverse tangent of 2 over 24. So if I go ahead and enter that in a calculator, it's approximately 4.8, which we actually discovered on number 1 is the max angle you're supposed to be able to have for a ramp. Number 4. A forest ranger sights a tree through a surveying instrument. The angle of elevation to the top of the tree is 27 degrees. So we'll say I'm looking through my eyeglass to the top of the tree. This angle is 20 degrees. The surveyor is 100 feet from the base of the tree. So I have the base of my tree down here. The surveyor is 100 feet away. How tall is the tree? Well, here's my tree right here. So I'm looking to the top of the tree, 100 feet from the base of the tree. How tall is the tree? So this time I have opposite and adjacent again, so I'm going to use tangent again. So the tangent of 20 degrees is equal to the opposite, which is 8, over the adjacent, which is 100. So to get h by itself, I'm going to multiply by 100 on both sides. And the height equals 100 times the tangent of 20. So in my calculator, I have 100 times the tangent of 20 is 36.4. So the tree is about 36.4 feet tall. Next one, a train travels at 5,000 meters along a track whose angle of elevation has a measurement of 3 degrees. How much did the train rise during this distance? So basically this train is going along a track that is slowly rising, and it travels 5,000 meters. And the angle of elevation between that track and the ground right here is 3 degrees. How much did the train rise, or how high did the train get? So I'm looking for this height right here. So I'm looking for the opposite. I have the hypotenuse, which is sine. So the sine of 3 degrees equals the opposite, which is 8, over the hypotenuse, which is 5,000. So I'm going to go ahead and multiply by 5,000 on both sides. And my height is equal to 5,000 times the sine of 3, which comes out to be about 261.7 feet is how high that train rises. The next question has several parts to it. So it says that the heights of several tourist attractions are given below. Find the angle of elevation from a point 100 feet from the base of each attraction to its top. So basically what you're looking for is if you're standing 100 feet from this attraction, what angle do you look at to see to the top of the attraction? So if I show you this first one, so here I'm standing, if I go 100 feet, I'm 100 feet from the base of the gateway to the West Arch in St. Louis, which is 1,368 feet tall. So what is the angle right here to the top of the gateway to the West Arch? So I have opposite and adjacent, which is tangent. So the tangent of x is equal to the opposite over the adjacent. And then if I go ahead and take that inverse tangent of both sides, x is equal to the inverse tangent of 1368 over 100. So if I go ahead and calculate that, I'm left with 85.8 degrees. So the rest of these are going to be set up very similarly because I'm just given new attractions with new heights. So Chief Crazy Horse statue is in South Dakota. It's 563 feet tall. and I'm still standing 100 feet away, and I still want to know this angle. So the tangent of x is equal to the opposite over the adjacent, and then I can take the inverse tangent of both sides. So the inverse tangent of 563 over 100 is equal to almost exactly 80 degrees. So my angle is 80 degrees. And then part C, I'm now looking at the Washington Monument, which is 555 feet tall. So I have Washington Monument, 555. I am 100 feet away. What is my angle? So I'm still using tangent of x equals 555 over 100. Take the inverse of both sides, so the inverse of 555 divided by 100, again, is really close to 80 degrees. It's 79.8 degrees, which makes sense because 555 feet was very similar to the 563 feet of the one before. The last one is the Statue of Liberty. So the Statue of Liberty is 305 feet tall. We'll say I'm 100 feet away, and I'm looking for that angle of elevation. So I have the tangent of x equals opposite over adjacent. Take my inverse tangent, and I'm left with about 71.8 degrees.